All right, thank you for joining us for today's GCE Ask the Experts webinar. Today's topic is on open pit slope design, implementation, and performance monitoring. And today's webinar is going to run for 1 hour from 9 to 10 a.m. in Arizona time. The webinar is brought to you by the Geotechnical Center of Excellence. We are within the University of Arizona here in Tucson, Arizona. And we are an industry-funded and member-led interdisciplinary center. We focus on providing collaborative and practical approach to geotechnical research and education with the goal of bridging gaps between academia, industry, and fields of study. If you're interested in the GCE, learning more about our research projects, our educational program, or membership with the GCE, you can email us here at gce@arizona.edu. We would love to tell you more. And as I mentioned, the GCE is a member-led and industry-funded organization. So listed here on this slide are all of our members who support all the work we do at the GCE, and they make everything possible. So we want to take a moment to thank them for their support. We really appreciate our members, and they are fundamental to everything that we do here at the GCE. So thank you to the GCE membership group. So the topic of today's webinar is design, implementation, and performance monitoring. Today's webinar is the 7th webinar in a series of 9 webinars that correspond with one of the professional development courses that's currently running through the GCE's professional development program. As you can see, there are many other topics that are included within this course. And if you're interested in the course itself, it is starting again in September 16th. So you can register for that session. We also have recordings of the previous question and answer sessions that were performed aligned with this course that are available on the current course site on D2L or through the GCE's YouTube page. So you can check those out. And then the course itself and the topics in today's webinar are also covered in a guidelines textbook titled Guidelines for Open Pit Slope Design, which was produced by the Large Open Pit Project in 2009 and is currently going through updates to produce an updated version that should be available in the near future. If you're interested in this textbook or the updated version of this textbook or other wonderful guidelines that the LOP produces on open pit geotechnical topics, you can visit the website lopproject.com to see those guidelines and to learn more about the LOP and its mission. And they have supported the underwriting of the course that I just mentioned. So we'd also like to thank them for that as well. And now to introduce the GCE webinar team who's here today supporting all of the questions that you will hopefully be submitting for our panel of experts today. So I am Jillian Noonan. I'm the moderator for today's webinar, and I'm a senior R&D engineer with the GCE. Along with me today, I have Julia Potter, who's the director of the GCE. Hello, Julia.
Thank you, Jill. Hello, everybody. Good morning. Thanks for being here. Looking forward to a great discussion.
And Cheryl Bukowski, who is our professional development program lead. Hello, Cheryl. Good morning.
Hi, everyone. Thanks for being here.
And Benjamin Meyer, who's a software engineer with the GCE. Thanks for being here, Benjamin, and helping out.
Hello, everyone. Thank you for joining us today.
All right, and we also, of course, have a great panel of experts who are here ready and willing to answer your questions today. And I will now introduce them. Here with us is Jeff Beal, who is Global Technical Advisor with Pateau Associates. And Jeff produced a module within this section of the course on surface water. Jeff, thanks for being here.
No worries, Jill. Welcome, everybody, and hope we have a nice discussion.
Thanks, Jeff. And also joining us is Dan Corkery. And Dan is a principal and senior blasting and vibration specialist with WSP. And Dan, of course, produced a module on controlled blasting. for the course. Thanks, Dan, for being here and for your contributions to the course.
Thank you, and glad to be here. Looking forward to a good discussion. Thanks.
Also joining us is Gustavo Gonzaga, who is the manager for geotechnical with Tech Resources. And Gustavo produced a module on rockfall management. Thank you, Gustavo.
Hello, everyone, and thanks for joining. And I'm pretty glad to be here as well.
And we have Bruce Murphy on our expert panel today. Bruce is a principal consultant with SRK and gave us a module on artificial support. Thank you, Bruce, for being here.
Everybody, welcome. Looking forward to a good discussion today. Thank you.
Thanks, Bruce. Also joining us is Thomas Beingessner, who is Chief Geotechnical Engineer with Tech Resources. And Thomas provided a module on model validation. Thank you, Thomas, for joining our panel today.
Thanks for having me, and hello, everybody from Canada.
And we have Serdar Ergin, who is Senior Geotechnical Engineer with Rio Tinto. And Serdar provided a module on slope design reconciliation. Thank you, Serdar. Great to see you, and thanks for joining the panel.
Thanks for having me today, and hello from Salt Lake City, Utah. Looking forward to our discussion today.
Thank you, Serdar. And finally, we have Paolo Farina, who is Principal Consultant with GeoApp and provided a course on a module on slope monitoring. Paolo, thanks for joining the panel.
Hello, everyone from Italy. Thanks for being here, and I look forward for an exciting.
Thanks, Paolo. All right, so for the participants that are attending live for this session, just to give you a bit of information on how this will work for you, you are muted and your video is off since this is a webinar. If you have a question for our panel, you'd like to communicate with our panel, you may use the chat for general discussions, or if you have a question on the topic of today's webinar, we ask that you please enter it into the Q&A. That is a button on your control panel. So if you click on that Q&A button, you should have a space where you can type in a question. There is a button you can select if you wish to submit your question anonymously. All participants should be able to see all of the questions that are submitted. So if you do see one that you think is a particularly good question that you would also like to hear the panel discuss, you may vote it up with a thumbs up. We are recording this webinar, and it will be posted both to the D2L course site and also to the GCE's YouTube page once completed. And then just a quick note that any views or opinions that are expressed by our panelists today are their own and do not necessarily reflect those of the GCE, and that all of the content in this webinar is intended for educational purposes only. If you do need site-specific professional advice, we suggest that you also seek that out additionally. And thank you for joining us today. So with that, we are ready now to start the question and answer portion of the webinar. I will invite any of our live participants at this time to submit their questions. And just a quick review of what topics we are looking to cover in today's webinar. So the overarching topic is design implementation and performance monitoring with regards to open pit slope design. And some of the modules that were covered in that section of the course, which our experts here are experts in, were surface water control and management, controlled blasting, rockfall management, artificial support for pit slopes, open pit underground interactions, slope monitoring, slope design reconciliation, and model validation. So we do have some pre-submitted questions that we'll go through based on these topics and the content within the course, but we do welcome our live participants to submit any questions in this realm throughout the webinar. All right, so we'll get started then with our first question. And for our panel, I will read out each question that is received, just to give you some time to consider your responses, and then I will open it up to the panel and or direct it towards the person or presenter who the question was directed towards initially. So this first question was for Jeff and or Gustavo, and then we'll open up to the panel. So This person asks, does vegetation on a slope contribute positively or negatively to surface water control? I would think that it would be positive impact by absorbing moisture. But then, does vegetation negatively impact slope stability? Gustavo's module listed that tree roots can be a trigger for rock falls. So all in all, is it better to have a vegetated slope or a non-vegetated slope, considering all of this and slope stability implications? So maybe for the first part of this question, I will ask Jeff if you wouldn't mind starting with that.
Yep, no worries, Jill. So I think the answer to the question is in most cases, vegetation is positive for surface water control and also positive for slope stability, and also positive for geochemistry and for post-closure pit lakes and post-closure surface water runoff. It's very well, vegetation slopes is very widely done in tropical areas, in Brazil, in Indonesia, and so they actively vegetate slopes, and they sometimes vegetate interim slopes in order to reduce surface water erosion. Now, in many of the, particularly the iron ore districts in Brazil, the vast majority of slope instability is caused by surface water erosion. So there's a major effort to vegetate slopes to reduce that. And what the vegetation does is it prevents channel runoff. It gives you sheet flow rather than concentrated flow, and therefore minimizes or reduces the potential to erode. And it also attenuates some of the water on the slope and reduces the overall runoff. So for most situations, it will be positive. And even in drier environments, we often try to get vegetation on the slopes for the same reasons. And again, just to reiterate, in pit lakes or in pits with adverse geochemistry, the vegetation can really be positive by covering up some of the reactive rocks that are exposed in the slope. So yeah. So I mean, in some cases, I'll let Gustavo take the middle one, but I think it's the majority of slopes start, in tropical areas start off with grassland and then develop trees. And by the time the tree is established, which typically is 4, 5, 6, 7 years, there's an understory of vegetation which tends to bind the slope together. So I think the Gustavi can chip in, but in my experience, the damage due to tree roots is often limited to the crest areas. So yeah, but overall, in my experience, and I've got quite a bit of it, it's positive to have vegetated slopes.
Yeah, I would add just agree with you, Jeff. Just in more like dry environments and maybe hard rock environments, in mining environments, usually the negative effect would be just open the joints by the roots that would grow over time. But as Jeff said, you have to compound everything together, right? So maybe there is an overall positive effect of adding vegetation, especially when you have a soil cover to the slopes. But if it's just like a bench style or just a fresh rock, you can have that negative effect of dilating the joints by the opening of the decrease in size of the roots, and even add an additional path for water to go through those fractures. But as mentioned by Jeff, like you have to have a view of the overall and where is your site and what's the best condition for it. Vegetation.
Yeah, I think where I've seen tree roots go into fractures and increase the potential for rockfall is actually in some of the older iron ore mines in the Pilbara in Western Australia. But it's in my experience, it's it's balanced out, more than balanced out by the positive effect of the vegetation.
All right, thanks, Jeff and Gustavo. I'll open this up to the rest of the panel if there are any additional comments or thoughts. feel free to unmute. But I do think Jeff and Gustavo covered that quite well. All right, thank you very much. And thank you for who submitted the question. We will move on to another that was pre-submitted. And again, let's see. Actually, let's do this one. So keeping it on the topic of surface water, Jeff, again, I will direct this question towards you to start and then open up to the panel. So they're asking, during a regular inspection and maintenance program, as you suggested is essential for integration of surface water management with mine planning, can you discuss what the staff on the ground or the aerial drone imaging should be looking for during these inspections?
Okay, so I mean, I think you know we're seeing as a geotechnical community that a large percentage of the instabilities we get, and even in drier areas, are related to surface water management. It's a key factor in geotechnical engineering and geotechnical performance. And I'm dealing with 4 or 5 instabilities at the moment, which can be directly attributed to surface water. And to give you a few examples of that, there's one large instability that I'm looking at in a large open pit in Mongolia where they had rainfall. They got erosion channels due to rainfall, and they had a subsequent rainfall which they hadn't cleaned up the initial rainfall erosion channels, and the subsequent rainfall got onto the slope and created instability. So an inspection program in that case would have identified that the original surface water plan was damaged, and they would have sent the right equipment out to deal with it. Another couple of examples. Again, there's 2 or 3 pits I've got at the moment where there's leaky pipes and leaky valves which have caused water to infiltrate into the slope. One of them has required a bunch of horizontal drains to remediate the issue. Another one I've been recently involved with has created a 32 million ton failure, which can be directly attributed to a leaky tank. So there's no substitute for getting on the ground and looking at the facilities and doing regular inspections. And I think in a wet climate, I think I would suggest that the geotechnical staff get on the ground at least once a week to all sectors of the pit, in particularly in the rainy season, and critically look at what needs to be fixed, what needs to be maintained, any leaky pipes, any leaky valves. And so then the second part of that is making sure that maintenance occurs to address those findings in a timely manner. So it's really getting the inspection programs in the first place and getting the procedures so that maintenance is done and prioritized to address the issues. And yeah, I mean, I think so. So staff on the ground, I think we've one operation I've been working on in Eastern Europe recently. We suggested they hire 2 additional people just to do the inspection and maintenance program and train them up in what they're looking for. Drones you can use. Drones are really good. In fact, you can program a drone to fly around the program, around all the installations. But you got to make sure you critically look at the footage, and anything that you see that's out of order, you've basically got to get out into the field, onto the ground, and inspect it. So I think it's something that I press really hard on most of our operations that I visit, because I just see so many instabilities related to inadequate inspections and inadequate maintenance. It's kind of my soapbox, so there you go.
Yeah, It's an important topic. I will open up to the panel for further discussion. Maybe some of those of you who are working within operations, Thomas or Serdar or Gustavo, if you have anything to add to that. Serdar?
Sure, Jillian. So for people who don't know me, I'm working for a Bingham Canyon mine. And our operational hydro team, they have a comprehensive surface water management program in place. So for our ground stuff, there are multiple locations that we're monitoring closely in terms of the surface water management. And those are mainly around the erosion channels or rills forming on slopes or haul roads, blocked or damaged drainage structures, such as culverts or diversion berms or drains. And we're also looking for water ponding or standing water in some certain locations in the pit, actually where we have some potential deformation locations or instabilities ongoing. And we also actively monitoring our seepage zones and our slopes with using GC's thermal camera. So all those findings then getting into our mine planning stage. So we identifying those locations where we have potential problems with the surface water and trying to eliminate those with making some additions into our mine designs. That's the process that we follow in Bingham Canyon mine. Thank you.
Thanks, Serdar.
I've got a quick comment.
Go ahead, Bruce. Thanks.
I guess one of the, exactly as Jeff has said, but a lot of times in tropical areas where we got all these pit perimeter drains, we put them in, they're all sitting on the plan, everything looks good, they have grades, they have everything in there, everything looks perfect. But fundamentally, you have a couple of storms, the grades in those drains change, you actually have a lot of standing water, and even though you've got it in the drain, the fundamental is it's actually still sourcing into your slope. So it's all those little things that make the massive difference to actually keeping that water out of your slope. So you have to check those things, even if they're in place, you've got to make sure they're working properly. So anyway, that's just a by the by comment.
Yeah, 100%, Bruce.
All right, any additional comments from the panel for this question? All right, we'll move on to another. Thank you so much. We do have a couple of live questions that have come in that we've grouped together. So I'll pull that one up. And this was provided by an anonymous attendee asking, have you had any success using alternative drone payloads such as thermal or LiDAR, and also any remote monitoring techniques such as multispectral satellite? So does anyone on the panel have any experience with these methods that they would be able to comment on this question?
I can provide a answer for using the thermal cameras. So we just recently started to use them almost a year and a half ago in Bingham Canyon mine. Those are creating a great monitoring information, especially during the night times, because most of our pit cameras are not getting that much resolution when the weather is dark. So the thermal cameras are helping us to capture some of the potential instabilities in the pit or potential rock falls. This is not a predictive tool, but this is more like capturing those events occurring. And in addition to that, we're also using the thermal cameras to identify the seepage zone within the pit. So during the cold weathers, when we see a seepage coming from the slope surface, mostly with a higher temperature than the air, so you can see those as the hot points in the thermal camera image. So this is also something that we're using to identify the seepage locations for thermal cameras.
Yeah, and I can kind of verify that the results that Serdar and his guys are getting are good. I think one of the other applications for thermal cameras on drones is going to be leach pads and dump leaches. We were looking at that last week for some large dump leach operations, just using thermal cameras to look at changes in moisture content in the near surface of the pad using drones. So I think we're going to see more and more of that. LiDAR with drones is, I think, coming quite commonplace. And the other thing that I've been seeing a couple of times with drones for my enclosure is when you can't access a pit lake because you've had ramp failures upon closure. There's now means to put water sampling equipment on drones and even depth sampling equipment on drones. So that's actually been pioneered by a couple of companies, and that's actually getting used. So drones and remote monitoring and remote surveys using drones is definitely going to become more and more. And you can imagine the payload for sampling equipment is pretty big. And so yeah, it's now been successfully done.
Yeah, just a comment from my side. Just all the things related to like rockfall or any movements besides the radar and scanners and those kinds of things. Drones are actually allowing you to do a lot of change detection, sources of rockfall. It's all kinds of things. It's really a fantastic tool for us to use. You know, all those LiDAR capabilities that we get out of it to actually look how those slopes are changing over time are fantastic properties for sure.
If I can try to cover the other part of the question, the one related to multispectral. I think multispectral is becoming more popular in the last couple of years. It is already used in tailing dams because multispectral data can be used, for example, to evaluate the signature of soil moisture or water and vegetation. So this is something that can be classified, can be identified over drone images. So that's something that could be done easily. And more recently, we have seen the use of hyperspectral data from drone, also in open pit mine, in particular to characterize, now to identify the presence of, for example, alteration on the surface, because this kind of hyperspectral sensor have the capabilities to divide the signature in a lot of very small bands, and this can be used to create libraries of different type of alteration on the rock surface. So this is something that is becoming popular as well.
Yeah, just a comment on Paolo's comment. Obviously, using that data to actually look at alterations allows you to get quite a jump on your domaining models in your pit, which are super helpful when trying to, especially in porphyry areas. So anyway, it's not the topic today, but it's a fantastic source of information to get you a jump in existing pit.
Well, definitely relevant to the overall topic of the course. So I say yes, relevant.
And maybe the only thing I would add as well is there have been some papers for the first question in recent slope stability conferences. I think we submitted one from Highland Valley, and I believe there was one done for Bingham as well, and that was in conjunction with the GCE there. And then on the second question, Louise, professor out of UBC, does have a paper similar to that topic.
And if you have any of those papers by any chance at hand, we'd love if you drop them in the chat for our participants.
Sure.
All right, since we're on the topic of monitoring, there's another question that is, in the same realm, but any additional comments before we move on to that? All right. So we have Paolo on the line. So Paolo, this actually is related to your presentation on slope monitoring. So I may ask you to first address this question, and then we can open up to the panel for additional discussion. The question was, in your conclusion slide in your module, you mentioned that, quote, too many mine sites have sophisticated monitoring systems, but are still not able to identify impending failure conditions. So the question is, why do you think this is, and what can be done to improve that?
Yeah, my experience is that in the last 15 years, monitoring technology improved a lot. And nowadays we have in place very, very good monitoring system. But the point is that most of them are mainly focused on safety critical, which means that the user is trying to understand whether we may have a failure, bench scale, multi-bench, or inter-ramp overall tomorrow or in the forthcoming days, okay? But the point is that sometimes there are, especially when we are dealing with large-scale instabilities, it is the monitoring data are not processed and interpreted in the right way. I mean, trying to identify indication of something that in the long term has the potential to develop as a large-scale instabilities. So I have seen sites that are capable of doing this, of course. I'm not saying that it's not happening. And to be honest, there are every day more monitoring engineers with an understanding of how to analyze data in a slightly different way, combining data from the different technologies, not trying to get, for example, from the vectors provided by Prism and GPS, the long-term trend, but also the orientation of the movement from satellite INSAR or radar subsampling, try to identify slow movements over large areas in their early days, and then trying to compare these with subsurface monitoring data like inclinometer, shape array, or piezometer, and then to close the loop using modeling to identify or to confirm whether a moving area has the potential to be stable at large scale or the opposite. I have from modeling an area with a low factor of safety or with the to squeeze our data to understand where we are already seeing something as a result of mining, no? Or as a result of the groundwater presence. So I think that there are still, despite the huge progress of monitoring in the last 10, 15 years, the data interpretation step is not necessarily at the same level as the data collection. I mean, we have very good data. The point is that sometimes at my site is not easy to really exploit the information content of those data. That's my
Okay.
what people are doing now in the last few years is probably going into the data analytics component. Now, try to put together the information you get from structural data, the information you get from groundwater, from modeling with monitoring. That's all.
Gotcha. Thanks, Paolo. Bruce, did you have something to add?
Yeah, just I think obviously monitoring, exactly as Paolo said, has made fantastic steps in the past years, certainly when I was trying to operate. But I think the issue is we've got a lot of that monitoring sorted. We talk about doing a lot of modeling, but once again, it also comes back right down to exactly as Paolo said, characterization of the geotechnical model and certainly the hydro as well. A lot of times we're doing these analyses and we're doing these back analysis and we're changing these dials. And if we don't really know what the conditions are, we come up with multiple realizations. So I think the statement is for us to get better at all these things, it's even goes right back to the characterization and steps right up to the subsampling and all those issues, trying to formulate how the failure is forming and then how we can mitigate it, I guess. And certainly a big topic that's coming up lately in slopes is, can we actually mine under moving slopes? And that's pretty interesting topic as well. Just that comment. Thanks.
Indeed. Thank you. Gustavo?
Yeah, no, just that in my experience, just agreeing with Paulo and Bruce, we have a lot of very good monitoring systems. We are acquiring a lot of data, but we are not spending enough time to do the interpretation of the data, interrogate the data, and try to identify those trends that are not obvious. Sometimes I see we are relying too much on specific types and don't spend enough time trying to understand the data. So I think that's just to add, that's the component that's missing is really that interpretation, spending the time trying to understand what's going on and look for new trends.
Thanks, Gustavo. All right, great question and good discussion by our panel. Any final comments before we move on to a new topic? All right, thank you very much.
Maybe can I make one more comment?
Yes, of course. Go ahead, Bruce.
I said monitoring was great. I think the one thing we are very good at is having all these external monitors out of the slope. I think what we're very poor at is actually having monitors in the ground. And I think the sooner operations realize that VWPs, TDRs, inclinometers are actually consumables that should just be chucked into the slope on a regular basis, the better we'll be. Because I think a lot of time we have this great monitoring of the surface, but we're not sure where the failure surface is. And we do all kinds of modeling trying to predict that. And if we don't know where it is, it gives you multiple realizations. Anyway, in-ground monitoring is just as important.
Jillian, also want to add a very brief on top of what just Bruce said. So that's, I think, the key for the future part of slope design modeling, because having these surface and subsurface monitoring data for a given deformation is a key to conduct the back analyses to inform the future mine designs. So having that data in place in the back analyses and informing mine design based on that, it's a key going forward for slope stability.
Great, thanks, Sardar.
It's something that we push all the time, and the experience is that you see deformation earlier subsurface than you do on surface. So that's a great point, Bruce.
All right, so just to note for our participants, if you check the chat, both Sardar and Thomas have put some papers in there that they mentioned. So you can go there and download those papers and learn more. And we have about 20 minutes left in the webinar, so I would encourage you to enter your questions now. And we'll get to as many as we can within the remaining time. We do have a question that came in, and we have also a pre-submitted question on the topic of blasting and blasting damage. So we have Dan Corkery here, who provided controlled blasting module and is an expert in the topic. And so I will ask Dan to please first address this question, and then the panel can comment additionally. And this came in from our live group from Wisnu. Based on its degree of severity damage on heavily jointed rock, could you please discuss what kind of blasting control needs to be applied to minimize damage for heavily jointed rock? So Dan, I'll ask you if you would be comfortable to address this first.
Yeah, I think, or for most types of blast damage, the controlled blasting relies on having a good method to relieve stress. So say for we need to keep the faces cleaned, and so if you're doing a trim blast, it's quite common for people to want to implement a trim blast, but when it comes, operations will indicate that they don't have time to properly prepare that face to minimize the damage that might occur. Excuse me, that might occur. So you have to do not only understand what type of blasting, but also be willing to put the effort into preparing the ground for that blast. For heavily jointed ground, the you don't want to, you might do something like post split, and definitely not pre-split, which is quite common. People will want to use pre-split for everything, and what it'll do is just end up causing more damage than solving. So avoid that. Maybe some post-split, and then something like trim blasts if you're able to do it properly, but avoid something that might. The reason we don't want to have pre-split in there is because it'll exacerbate and maybe even create more problems behind. So quite often people will use a post-split, or but definitely trims are a nice approach, because they and the trims at an angle, not right angles to the face, at a low angle, are quite commonly used.
Thanks, Dan. I see some other nodding heads from the panel. Are there any additional comments?
Yeah, maybe just a quick, I totally agree with Dan. I think there's a lot of blocky, weak ground where people are using splits that I don't think it's worthwhile. I think my terminology is a bit different to Daniel, and sorry for that. I call it buffer blasting, but anyway, it's probably trim blasting, where you use that double stitching on the back with that half spacing and those tight spacing of holes. I think that realizes really good stuff. But then certainly there's line blasting. Well, certainly in a porphyry, I've seen our friends at Kisledag do a hell of a job in terms of realizing steep benches with line blasting, but that's not really jointed rock mass. It's more really weaker. So that's a comment. Totally agree. Sometimes we are implementing these massive programs of pre-split, where I think we can do other things to keep it tidy, for sure.
Yeah, and regarding line drilling, I like to see some good ones. There's quite often it's difficult because the cost is prohibitive. And if you can do it, that's good. And what we had luck with was when people were trying to use line drill and they weren't getting good results. What we did is a sort of a hybrid, where we would use every third or fourth hole, we might load like a pre-split round, and just to induce that perforation. And it's not it's kind of a hybrid, but line drilling sometimes is a difficult one. But yeah, there's always, and in any of these cases, it's always going to be a matter of or in most cases, optimization. So you'll do something, and then you'll have to modify it to get closer to what you would anticipated.
Again, I see Bruce nodding his head.
No, it's totally correct. It's trials and trade-offs, and that's what we have to do to get where we want to be. Anyway, yeah, great.
All right, thank you, Wisnu, for the question. Before I move along, any final comments on this? We have another question related to blasting damage that I'm going to pull up next. All right, so this question is again addressed to Dan, but also Serdar and the panel. So understanding that the idea is to maximize the, quote, damage to the blasted material to produce rubble, but also minimize the damage to the bench face behind the blast. First question, is it possible to predict the extent of damage from blasting practices to a bench face? And then the second part of this question says, I do understand from Serdar's presentation that post-blast performance assessments can be used to improve future blasts. So in the same idea, is there a way to measure or quantify blast damage or extent after the blast? So maybe Dan, have you start with talking about the first question, and then we can address the second one following.
Yeah, most of the ability to predict the extent of damage is from past experience, either on that site or related, or a site with similar geology, but it's always going to rely on observations afterwards, so quantifying it or understanding what went wrong if we have more damage than anticipated, and working from there to modify your blasts, and as far as predicting the extent, it's in many ways it's difficult because there's so many parameters, and you might have an idea of how much you might have a perfectly reasonable blast design with minimal blast damage. However, if you're not on site to observe what's going on, small things can get in the way of executing that properly. And quite often I've had it where we provided a design that will minimize damage to the remaining wall, and yet it doesn't work out. But what happens is it wasn't executed properly. So it's a matter of predicting it based on experience, predict primarily from the site. So as you're going along, as blasts proceed, understanding what may have caused an increase in the damage, and then modifying your blasting going forward. But you also have to have someone you have to do your either your QA QC or audits to understand what's really going on, because you quite often you won't know what's going on, and the design may be wonderful, but the execution may not be.
Thanks, Dan. Serdar, did you have something to add?
Yeah, maybe for the second question, I think the short answer is yes. There are measuring techniques to quantify the blast damage following the blast. So few implementations that we have here in Kennecott and Bingham Canyon Mine, we do a kind of like damage mapping, like the visual inspection after the blast. This is kind of like a field mapping to observe the overbreak, the bake break, or irregularities on the bench face. There are some softwares to help you to do that reconciliation to understand the blasting impact. On the other hand, we also get a high resolution photogrammetry or LiDAR scans to generate a kind of like pre and post blast point clouds and softwares to understand how the bench face behaved before and after the blast. So this will give you the damage extent by just making that comparison. And also we are using seismographs, which is basically a seismic monitoring, kind of like vibration data during the blast with signature holes to understand how the production or trim blast impacting the slope stability. And we also look into the details such as like the P-wave velocity surveys to assess the reduction in rock quality or stiffness for post-blast. And I know some other techniques as well that I don't think we're using at Bingham, but the blast movement monitors, there's some hardware tools available for you to monitor the blast. But we collect all this information, and how this information gets into the future blasting practices. So this is a kind of continuous improvement loop here in Kennecott. We use all these findings to calibration of our predictive models based on the actual outcomes, and using them to improve our blasting practices to reduce down the damage caused by the blast to the slope faces, and basically reducing the variability in wall performance over time.
Yeah, sounds like a really good program. But it's always a continuous feedback loop for sure. And how is the don't want to sidetrack, but how is your monitoring, your seismograph monitoring? How is that fed back? Is it successful, or is it helpful, or?
I'm not a blasting expert here. I'm a geotech engineer, but in every blast, we do near a continuous deformation location or potential instability. We do use the seismic monitoring, and our blasting engineers and geotech engineers get that information. If we see a kind of damage on the slope walls caused by the blast, then we try to adjust the blasting inputs for the next bench blast and monitoring it according to the seismic data that we observed from the previous one. But there's a lot of components coming into that, like your structural variability or your rock mass properties, etc. But yeah, we use it to optimize the next bench blast based on the information we obtained from the previous one.
That's really good, because quite often operations might think of it as a one-off. So bring the seismographs in, do some near field monitoring, and then on your way. Whereas it's if you're going to be doing this as an ongoing piece of your optimization, that's where we're trying to head.
Yeah.
All right. Thank you very much. There was another question just from the live group here in the same realm. So Dan, do you have any tips to stop vibration right in front of the design slope? Let's say the wall or bench doesn't break, but due to just the vibration, the joints then indicate that they're opening their aperture wider.
Dan, you're on mute.
Yes, I'm in digest mode.
Yes.
Yeah, I mean, to stop, from what I understand, what the question is asking is this: you can't stop the vibrations, but to minimize the vibrations from impacting the wall is one of the key things. Is well, not only the orientation of the blast, so you don't want these things at right angles to the intended the design slope. You want them at a lower angle, but there's also again, I don't want to harp on it, but it's always a matter of reduce the amount of restriction and that you have. So clean that face if you can. Allow that muck to move out, and the vibration level, as well as any kind of gases from that blast, will be able to release more quickly and not have as long to operate on any kind of joints in the remaining wall. So clean the face, and if you want to minimize them, there'll be things like reduce the hole diameter as you're getting closer to the final wall, and for trim blasts or such, you might want to have a lower hole diameter, or including the gap in the anyway, I'm getting to the age where sometimes I'll get a block, but reduce hole diameters or any other methods to minimize the amount of explosive damage or energy that's coming from those holes. So quite often, instead of just one row of reduced holes in front for your trim shot, you might want to have 2 rows of reduced hole diameters, and as well as maybe an air deck is also will reduce the explosive energy that's going to hit that wall. Those are the, you know, that and making sure you've cleaned that face to allow the free movement, because the free movement also not only one of the key things is it allows that the gases that are going to operate on any kind of joints behind, it'll allow them to reduce more quickly. So any kind of, you know, clean the face, reduce the explosive energy at that wall, so reduced hole diameters, maybe air decking. Is that what?
Yeah, that's good. Thanks, Dan. Bruce, did you have something to add?
Yeah, I think I can't agree more with Dan on the free face requirement. Just another comment, nowadays, a lot of people are getting into hybrid blasting. They're thinking electric deaths are solving everything. So they're actually doing the trim plus the production blast adjacent to it, trying to optimize production. I think we've got to watch that. And certainly as geotech engineers, we've got to make sure those evaluations are working. The other thing that's happening is there's a lot of tight cuts. People are trying to do center lift blasting and all that kind of thing. We need to do the monitoring, and we need to put those seismographs on the block and on the slope and get a feel for those PPVs and frequencies and understand those things quite classically. I think the production guys now are actually pushing. Let's blast big blocks. We do it with electric deaths, guys. We're keeping the energy down. Well, let's make sure we chart what they're doing and check what they're doing and make sure we're not actually lifting the trim or actually having a good go at lifting the slope in terms of instability in that damage zone. Anyway, sorry for the diatribe.
No, that's I could agree more. What we've had over the last several years are people thinking that implementation of electronic deaths, which have their place and do provide do provide benefits, but they're not a panacea, and they definitely don't overcome a bad blast design. So understand, you know, do the work on the blast designs. If you can, if you think that the electronics are going to help, but you have to do the follow-up and understand, did they really help, or was it the same result, or whatever. But it's a matter of understanding what happened afterwards, and, you know, making observations and conclusions about what you did, and did that help.
Again, I see a lot of nodding heads from our panel. All right, well, thank you very much for that discussion. Unfortunately, we are out of time for this webinar. As I said, they go by fast when you're having fun, but I wanted to mention for just everyone here who's participating in this webinar that, you know, the topic of this webinar covered a wide range of topics related to design implementation and slope performance monitoring. If these are topics that interest you, the GCE does have focused courses on both slope performance monitoring and radar monitoring that are currently available for registration, that are running right now. So the radar monitoring course covers in detail all ground-based radar, satellite-based radar, and everything to do with that. And then the slope performance monitoring covers all other monitoring tools that can be used both on the surface, subsurface, to monitor displacements and water and all the things you need to look at for geotechnical stability of slopes. So you can look into those two courses. And then also we got on the topic of blasting, which is something that's been shown to be a big interest for our stakeholders. So I wanted to also note, as Julia put into the chat, that we are currently developing our newest course, as indicated by interest by our members and stakeholders, is going to be on blasting and pit slope performance. So you can look forward to that course being available later this year. So lots of different ways you can learn more. If your question didn't get answered today, there will be some upcoming webinars associated with the slope performance monitoring and radar monitoring courses. So you can watch our LinkedIn to look out for those and register for those and bring those questions again. And our next webinar for the Fundamentals of Open Pit Slope Design course is going to be coming up and will be focused on risk management next. So you can look out for that as well. And if you're interested in the Fundamentals of Open Pit Slope Design course, again, I'll show this here on the screen. So thank you very, very much to our panel today. We really, really appreciate you giving us your time today. It means so much to us and to all of our participants. So thank you very much.
Great discussion. Thank you, everybody.
Thank you, everybody.
Thanks, everyone.
Thank you.
See you later. Bye.
Thank you,
Thanks,
everyone.
everyone.
Bye
Bye.
bye.
Bye-bye.
Thank you, everyone. Bye bye.
All right. Thank you to our participants. We'll hope to see you in our next webinar. Everyone have a great day. Thank you so much.
Cheers.